welcome from my side. After having some refreshments, I would like to introduce you to the next topic that we have in this evening. My name is Lechner. I'm heading the architectural department of custom development at MSG Systems. And within the next 1 hour, I will give you a short introduction to text analysis on SAP HANA. So first of all, I want to give you a short motivation. Why is it interesting and why is it important to deal with this topic, text analysis? And after that, I will show you how text analysis is working and what you can do with it within SAP HANA out of the box, which is the second point. And then I will show you the enhancement options that you have within text analysis in order to adopt text analysis to your needs, which is also essentially possible and necessary. Okay, so what is the motivation? Well, the motivation is big data. Currently, big data is a really hot topic. Everybody's talking about it. Nobody is knowing what it means. And the question is, what is hidden behind this term big data? So I have cited here several studies concerning data in general within companies. And for example, Merrill Lynch says that 80 to 90% of all potentially usable business information within companies originates from unstructured data that is located within the companies. And according to another company or society, Computer World, there is also a comparable number that unstructured information may account for more than 70 to 80% of all data within companies. And the point is that this data that's already located within the companies will grow over the years. And there are studies that it will grow approximately to 40 zettabyte by 2020, and maybe even more. Now, where does this data come from? Well, there are several sources where it might come from. It might be social networks. It might be call centers, where the company interacts with the customer. Or it might be something like letters from the customer. And letters, really printed letters that are scanned, email, feedback forms, feedback form like you filled out before, in the talk before. And that's where the data comes from. Now the question is, what's the problem with the data that is there in the companies? I mean, it's there, it can create value. Well, the problem with unstructured data is that it's unstructured. So it's not well organized. You have no data model that you can use on the unstructured data. So there is no predefined data model. And you have either no metadata on this data, or you have a mixture of data and metadata. Summing these restrictions up means that you have limited to no access to all the data you have within your company. And it doesn't matter if it's a lot of data, if it's really big data, several zettabytes, or if it's just some gigabytes. You have valuable information within your data, but you cannot access it. So that's really a problem for companies. And that's where the topic of text analysis comes in. Text analysis is the bottom line in order to solve this issue mainly by extracting high quality information out of this data. So you have this unstructured data, you know there is something in there somewhere hidden in this data, and text analysis gives you the opportunity, the option to extract this information out of the data. So what is text analysis? Well, typically text analysis contains these steps, mainly parsing the text, going through the text, adding features to the text, like linguistic information. Is this a noun? Is this a verb? Whatsoever. And inserting this extracted information in a structured manner into the database so that you can work with it. There are several examples for typical text analysis tasks. For example, entity recognition. So it's not sufficient to know that this word is a noun. It's not sufficient to know this word is a verb. You need to know, is this noun an organization, a person, a place? What are the domain facts that are linked to this information? So this is one part that's typical text analysis. And then what Victor already showed you, sentiment analysis. So what attitudinal information is hidden within your data? Think about a new service that is broadcasted by a company. Think about a new product. You launch it onto the market, and you want to get information. What does the customer think about it? So you go to social networks, you extract the data, it's unstructured. Bad luck. So you need to extract it somehow. And what's also an important point is the relationship between the data, so the contextual information, the fact extraction, and the event extraction. So this is all linked to the topic of text analysis. And now the question is, where does now SAP HANA come into play on that topic? You might have seen this picture either last year or somewhere in a press release by SAP or in the sub-community network. This is now a complete overview of SAP HANA with all these cool features that SAP HANA has. You have the complete platform in the center of it. You have the database layer, these database services that are somewhat also available in the HANA Cloud platform. You have a lot of options to integrate it. As we heard before, you have some development tools that you can use and that we will see later on. And you have processing engines. And there is one processing engine that's often forgotten when talking about HANA. So what's always in there is predictive analytics. What's always in there is spatial. Also, the planning engine is quite of importance. But what's a little bit overseen is that there is also text analysis capabilities within SAP HANA. And they are quite powerful and already quite elaborated in order to use them. So some clean basics about text analysis within HANA. Well, what do you need in order to do text analysis? You need the text within a database table. That's the bottom line. So first of all, you somehow need the text within SAP HANA. And then this text has to be in some format that is readable by HANA, by the text analysis of HANA. And this can range from a classical text column up to a blob column, which means that you can also store PDFs, Words, and so on. And then what you do next, when you have the text within the database, you create a full text index on that table, on the column to be more precise. And this is a screenshot of all the options that you have in order to create this full text index and in order to get out the data of your unstructured data. So I will not go into each and every detail. We will not write a test after this talk on this syntax. So what you do is, I mean, quite self-explaining, you create this full text index. We will see that later on in the demo on the table where your data is stored, and you specify the column where the text is located. So that's easy. And then you say to SAP HANA, switch the text analysis on. And then there is one very important point in order to create the full text index, and that's this line here. It's the configuration line. This is well, where the magic happens. With this configuration, you tell the system at what point of view it should take in order to extract the information out of the data. For example, shall it do a lingual analysis, just tokenizing the text and telling you is it a noun, is it a verb? Or shall it do something different? Shall it do sentiment analysis? Then you also can specify the languages or the language column, so the column in which a language is located in order to go to the right dictionary, because internally the system has to know which languages is text written in order to specify or to take into account the right dictionaries to extract the right entities. You can also let the system itself search for a language, but that's not supported for all languages. For example, Japanese, Chinese are not supported. As I mentioned before, you can also put into the database some PDF files, some Word files whatsoever. Then you can specify here a column where the MIME type is stored. And what's also interesting here, for example, is this line here down below, token separators. So first of all, when you want to do text analysis, you want to extract the information, okay? But when you dive a little bit deeper, maybe this information is stemming from a chemical industry. And usually when you separate your tokens, you might have dashes in between, straight lines, which indicate that their token is broken. If you want to do this, for example, in chemical industry, where you have chemical formulas, where the elements, the molecules, have this line in between in order to make the chemical formula, this would be a problem. Because then you would separate chemical molecules within your text analysis. That makes no sense. So that's then something that you can steer with this part of the syntax. So as you see, you have a lot of options in order to deal with text analysis. And now let's take a look how this behaves within the system. So what I have here is a SAP HANA on-premise system. It's not a cloud system. I use the web development workbench. And what I've put here into the database is, well, a very basic table consisting of a column that's a string column. And there are several sentences in that. As you see, it's like Christian loves SAP HANA, Christian loves BF Plus even more. This, I think, answers the question concerning the pricing of HCP, especially fetching the prices of SCP. And as you can already guess, that's also something that what we will use in order to do the sentiment analysis. But nevertheless, these are full sentences. You have a full stop at the end of the sentences. And now let's see what happens if we do our very, very first text analysis on that. And as I mentioned before, all the magic happens here. You create a full text index, and you specify a configuration. This configuration says it shall compute a full lingual analysis. We will see what's the result of that. And, well, let's let it run and see what the system does for us. Can ignore the error message. First of all, the system created a new table. This table represents the full text index. So as you can see here, I specified my name for my full text index, and now I have a table that's called my full text index. And this prefix is automatically attached to this index name by the system. And it's always the same. It's always $TA for text analysis _. And this is where my full text index is stored. And now let's take a look how this index looks like, or of what columns it consists. There are several columns in there. And, well, first of all, you can see which rule was applied within your full text index search. There is a counter counting the words that are within your text. Then there are the tokens. This is the part where the interesting stuff happens. So this is where the system identifies a noun, identifies a noun group. What's written here within the database table is highly depending on the rule that you apply to the text analysis. Then you have the language that is used, and then you have some further information classifying the token. For example, which type is it? What is the normalized form of it? When you think about languages like German, where you have Umlaute, you want to normalize it in order to get rid of the Umlaute. The stem of the word, and also some further information, which is not of relevance for our case here, but would be of relevance if you have a really large text, a document, and you want to know in which paragraph does this token reside, in which sentence does the token reside. And there are several further information like this one. This came into the system with SPO9, so it's a quite recent feature of text analysis. This gives you the relation, if you do a more complex analysis on the text, between tokens that logically belong together. So if you have a sentiment expression, Christian loves HCP, that's one token. And then loves is one part of the token, and HCP is one part of the token. And then this column links these three tokens together. So that's enough for the theory. Now let's take a look what happened. Let's take a look at the content of our text analysis. So that's what happened. We have here now the rule. It was lingual analysis. That's abbreviated with LXP. And then we have the interesting information that comes here. Yeah, it's fitting. So we have the token, as you can see, was properly tokenized. You see the verb, add a type. Is it a name? Is it a verb? Is it a determiner, a noun, and so on? Then you see here the normalized form, so it's all written down into lower letters, and well, it's in English, so I have no umlaute. And you also see that there is the stemming. For example, gives, the word stem is give. So out of the box, SAP HANA already provides you with a functionality that allows you to do some lingual analysis. That's okay, but that's not really cool. So the really cool stuff is that what Victor already showed. But I will now allow you to take a look behind the scenes. So Victor showed you the result, and I will now show you where this happens. So the name of the game is entity extraction. So the interesting part of text analysis from my point of view is not the lingual analysis, it's necessary, but the interesting part is entity extraction. So here you really extract information depending on the context that you want to take a look at. So SAP delivers several configurations in order to catch up with that goal. And these configurations focus on entity and fact extraction. So we have one extraction core, which is a very, very basic extraction functionality. It's more, well, the pillar in order to build other extraction configurations. And then we have these three additional extractions that come with SAP HANA out of the box. You have Core Enterprise, which is something that you can use in order to well, make some analysis on stock market, for example, or from market information, one company buying another company. It will extract all the relevant information, which company is the buyer, which company is the one that is bought, and so on. Then you have Extraction Core Public Sector. I do absolutely not know why it's called public sector. What you can get out of here is information like when you did a journey and you wrote some lines about your journey, from where did you go, what was your destination, how far was it away. This configuration extracts you all this information and tells you this was the destination, this was the distance, and so on. And this last configuration, the voice of customer configuration, is the one that extracts you the sentiments. So once again, let's take a look at the system. I will first of all show you the core extraction functionality. So what comes out here, because we will see here something quite interesting from my point of view. So I will refresh that one. So as you've seen, or as you might have seen, the number of rows changed because the extraction configuration is different now. You also don't have a complete tokenization, meaning you break the sentence down into its single elements, but you build logical groups. For example, Christian loves is a noun group. Bad documentation is a noun group. As you can see here, Romania is a country. What is quite interesting is HCP, HANA Cloud Platform, is recognized as an organization. That's, from my point of view, quite interesting that that's part of the standard configuration. So I have now to scroll somewhat around. Okay, I'm now missing something. So usually this should be identified as a product. Okay, then let's do the voice of customer extraction. So it's once again It's the same syntax, so there is no magic in here. You give the configuration to the full text index creation, and the system does the rest for you. So let's see what happens now. Nothing, which is not good. Okay. Okay. I was now slightly sweating. As you can see now, the system extracted the sentiments. So for example, here, it identifies that this token is a sentiment, and then it further down specifies that hates is a very strong negative sentiment. Christian loves SAP HANA is also sentiment, and this is a strong positive sentiment. So as you can see here, this is exactly what happened behind the scenes when you filled out this feedback app before. The text was taken, it was stored within the database, a full text index was created, and the full text index used exactly this configuration in order to extract the information. So, well, this is what comes out here. What you can see here, in difference to HCP, is that SAP HANA is correctly identified as a product. So they are one step ahead. BRF Plus is also not identified as a product, so they have to do some work there, I would guess. So what's also interesting is, and there I have to contradict Victor a bit. So it's really taking into account the context where the sentiment is extracted. Take a look at interested. Interested is a weak negative sentiment. Why? Interested is usually, well, it's not really positive, but it's weak positive sentiment. But the context was Christian is not interested in. And it took this complete sentiment token and then extracted, depending on the context, the weak negative sentiment. So it's quite some power in there. So that's it for the stuff that comes out of the box. I think that's already quite powerful. It's not as sexy as UI5 if you do this SQL stuff, but I mean, you have to do it in order to get information. We want to create value. And the point is what you also saw, even with this example, we used two products of SAP, BRF Plus and HCP. And both were not recognized by the system. Now think about company industries where you are working in that are completely different from IT business and have their own syntax, their own slang. You need to adopt all the stuff in order to do a reasonable text analysis within different industries, within different, well, slangs that are used in order to get the information out that you need. And SAP HANA allows you to do that. And there are several options how to do that. And I want to present them to you. So first, the first option is just to create a custom dictionary. Dictionary is really that what you think it is. It's listing the entities that you want to extract and somehow classifying them. The structure of a dictionary is as shown here. So you have a real-world entity. Let's take this United Parcel Service, which is a real-world entity. It's a company. And you assign that to a specific entity type. Because this is what you would, well, extract if you read a text about United Parcel Service. It's a company. So, and an organization. So you have here an entity type, which already represents a small hierarchy. Organization at commercial. And this is now mapped to a standard form name. So whenever a text is searched and exactly this word appears, this entity type is attached to this word and is stored within the database. Then you can also define variants, because I think not many of us would describe United Parcel Service as United Parcel Service of America Incorporated. So you have to define variant names in order to get all this other stuff like United Parcel Service, like UPS with dots in between, and so on and so forth. So you can define them, and you can even define or add some information to that by saying, okay, this is the official abbreviation of my real-world entity. And you can then use these dictionaries in order to extract all the information. And what's even more important, you can create these dictionaries yourself and use them within your custom code configuration or your custom extraction configuration. And the workflow for that is really, really simple. So first of all, you have to find an extraction configuration that you think might be fitting for you because you do not want to build them from scratch. You will see later why. You copy the configuration, you create a new custom dictionary. That's quite easy, it's XML. Then you reference the dictionary within your configuration, so we go in now one step back, and then we recreate the full text index. So let's see if we can get out HCP as a cloud product in the next few minutes. So I will now close this all. So first of all, we have to find a configuration. And SAP is quite nice because, not this folder, but this official SAP folder, it stores all the configuration within the TA folder on each system. So TA for text analysis. And what you see here, within every system, you see the dictionaries that SAP uses in order to extract the information. So let's take a look at them. If you think about the sentiment analysis, SAP has introduced some abbreviations for that. SPS is strong positive sentiment. And that's exactly the words in alphabetical order that it uses in order to extract a strong positive sentiment for an adverb. So it takes a look, is it an adverb? Then it compares against this list, and if it's a match, it's a strong positive sentiment. So no magic what SAP does here. But that's not what we need. What we need are the configurations, and they are stored here. So you have here all the different configurations. And for those of you who have already worked with HANA, you might know that the important thing is the ending of the file. So here you have HDB, HANA database text dict, it's a dictionary. HDB text config, it's a configuration. So what we need to do is we copy a configuration, we take the configuration core, copy it. No, I do not want to open it. Opening is a bit dangerous if you did not define your roles within HANA correctly, because there is no modification assistant within HANA. So you can happily modify the original source and you will not get aware of it. So we paste it here. Again. Copy it. We paste it. And we rename it in order not to confuse it with the other one. So we say it's extraction core underscore conference. And then we also need this new file, this new dictionary that we will create now. And we call it cloud.hdb text dict. So it's a dictionary. And as you certainly don't want to see me type, I have prepared a little bit of code in order to define the dictionary. And what you see here now is just a few lines. And you say, that's the entity category. That's the top of the picture, if you remember it. Cloud platforms. And then you just define the entities, which is standard form, like Microsoft Azure, like SAP HANA Cloud Platform, like Amazon Web Services. And then you define the variants. And then you also have one very nice feature is variant generation. When you think about a company, there are always these abbreviations at the end, limited, incorporated, and so on and so forth, with a lot of variants, how you can write it, how you can abbreviate them. And with this additional part within the configuration form, you tell the system, hey, I don't want to specify all these variants based on this last term. Please create them for me. You can also create your own variants that are then generated. That's all possible. So it's, as you see, it's very open. It's very well intended to be enhanced by the customer. Okay, we saved that. And what we have to do now is put that into our custom configuration. And now you see the reason why I copied it. There is a lot of stuff in there that is not, well, intuitively written down at a glance. And there are also some comments that are, well, making you aware that you should have that within your configuration file. But there's also one section which is intended for enhancement, and that's the section here down below. So you can extend the extraction analyzer, so the extraction process with your custom dictionary. So once again, I just add my little custom configuration here. And what you see here is, all I did was, I said for my custom configuration, please consider a new dictionary. And I tell him the path to this dictionary. So where should the system look for a dictionary in order to use it? And I activated the file, that was it. And what I do now is call it. So in difference to the calls before, I now have to specify the full path to my configuration. So it's located a little bit different than the other ones. So I now do it, and now let's keep our fingers crossed. It worked. And what you see now is HCP is recognized as a cloud platform, SAP HANA Cloud Platform. So it was, I don't know, time is running. 3 minutes in order to create a new dictionary, if you know what you have to do to enhance the configuration, and you can very easily extract new information. You can very easily use that in order to take a token and bring some meaning to this token. So that's already quite interesting, and I think it's cool. But I think it's not the end of the path, because, as I mentioned before, what if we have to do real text analysis within an industry-specific context, or mining for slang like words, facts, and entities? Think about sports. Sport is a very good candidate. There is a very own vocabulary that they're using, and this vocabulary often only makes sense within a certain context of a sport. As you might know, I'm from Germany, from Bavaria, so you can think which example I have taken. I will take for the next demo. So it's CrossFit. If you read the first database table, you might have seen that I'm absolutely not interested in soccer. The point is that there are really some funny facts to extract, which only make sense within one specific context. Now the question is, how can we extract really complex entities out of some text? If you do not know what CrossFit is, I can explain you later, or you can ask them. How can we extract really complex entities from a text? Like, did somebody attend a CrossFit training? It's not sufficient to specify he was training. There have to be some other words within the text in order to say, yeah, this was a CrossFit training. That also goes for soccer training. Or what's interesting from a business point of view, for example, does somebody want to join a CrossFit box? Does somebody post on Twitter, on Facebook? Yeah, I'm quite interested in. Well, I can fetch that information, for example, using the Twitter API, and then I can directly market perhaps my CrossFit box. But before we go to the fun, some facts. SAP HANA also allows that, for sure, because otherwise they would not be able to do more complex extractions. And this is done via extraction rules. You can think about extraction rules like some rules that are based on regular expressions in order to make a pattern matching and in order to extract the information that then matches the pattern. The goal of the rule sets are to extract really complex facts and relationships between entities, then entity-to-entity relations in order to, well, associate entities to dates or times or locations. Then, what is the thing that we will do? Identify entities in a domain-specific language, or capture facts within a new or popular slang, which is very difficult if you would do that with dictionaries. Think about all the variants and think about the context. It's impossible in most cases. These extraction rules now have somewhat more ingredients than a simple dictionary. Mainly they are based on dictionaries, because you need dictionaries in order to extract the entities. Then you have something that's called token. That's the basic unit that is used within an extraction rule. Then you have regular expressions, fun for themselves. And you need to have luck. Why do you need to have luck? I think you already saw that. There was no syntax highlighting. There was no code completion. There is literally nothing in the web IDE nor in Eclipse in order to support you in writing that. So what usually happens when I prepared the demo, and thank God it's air conditioned so I'm not sweating, I tried it out, I made some typo, I built the full text index, I put the refresh button, what happened before, 0 rows. You take a look at the coding and say, somewhere is an error, but I don't know where. You cannot debug it, nothing. So it's fun, and hopefully it works. Okay, now I will now very briefly go about the ingredients of such a rule. Just to make you aware what are the single parts as I mentioned before, that's not something that you have to remind. At least not until the end of the talk that's coming after me. Tokens, as I mentioned before, are the syntactic units of a text analysis. So they are the base. They are represented by these brackets, and they can have either a string in them, the stemming of the string, or a position tag, where the position tag means is it a noun, is it a verb? For example, if I want to search for a word that, for a verb that has activation, activate something in there, and has the stem activate, as you can see, you can also use wildcards here, then that would be the token that has to be used. Next, you have additional operators that you can work with. You have wildcards, you have alternations, ORs, logical ORs, and so on. You have so-called iteration operators, so you can say how often should a token appear before the next token that I'm searching for shall appear. So that's also possible. Then you can use grouping, we will see that later on, like just grouping tokens or introducing ranges. And what you can also do is use expression markers. These are very important because with these expression markers, you delimit the search term. So usually when you do text analysis, you're not working like in our demos on one sentence within one column of a database table, but you have a really long text, and you do not want to make a pattern matching over the whole text, but perhaps restrict that to a single sentence. Whoops. To a single sentence. And that's what these expression markers are made for. So here, for example, you have a sentence marker. You can also search the whole paragraph if you want to. You can also mark single entities or clauses. So you just have to put some limits on the search in order to make it reasonable, and that's possible. And last but not least, you need directives, which are then the facts that are extracted. These directives is something that allows you to build modules in order to be more capable to handle the text analysis. So it's like spaghetti coding. What you can do first, put all the stuff within one file, and at the end of the file there is somewhere a directive that says this is the entity that I want to extract. But that's not good coding, and that's also not good for text analysis. And these directives, allow you to structure your rules. And they also allow you to make some reuse. For example, you can define subgroups, which are then used within groups. Or you can groups and reference them within other groups, like is done here. So you have the group HANA, and then you have the group HANA native, which is a token that, or an entity that consists of the group HANA and this token here. So you have a lot of options, and we can now take a look at these options. So what I will do now is comparable to the stuff I did before. So first of all, I need to have a configuration in order to address my new rules. And I just copy the one that I used before. And I call it CrossFit. First, I do not do anything to that. And then, as I mentioned before, I also need a new dictionary, which is called CrossFit.hdb text dict. Let's put that in lower letters. Did he create it? Okay. I mean, it's a live demo. Yeah, here it is. Okay, now what shall we put into the dictionary? What terms do we need? Well, first of all, we have to take a look at the text that we want to analyze, and for that I create a little column, and I also let run a little standard text analysis on that. So let's take a look what funny facts we can extract. We have a new table. We open the content. Okay, so as we see here, there are 3 sentences in there. One is a classical VOD, is death by pull-up. As you can see, death by would have a completely different meaning within another context. My cat is what today? And one exercise was skin the cat, which was a torture. Torture and skin the cat might have a completely different meaning if it's outside CrossFit. And John had is what today, a very basic sentence. So as you can see here, you cannot create a dictionary that takes into account this context information. Skin the cat only makes sense as an exercise if there was something CrossFit specific before or some industry specific stuff before. So this is something that we have to take into account. So okay, then let's first create our dictionary and put in all the terms that we need. As before, I have prepared something for that. And as before, as you can see here, it's the same. So I define some entity categories like workout, like CrossFit, like workout type. And I put in some entity standard names, some abbreviations, and so on and so forth. And what you can see here is, for example, skin the cat. For those who did not know it, it's a very good app exercise. So that's now the basis for our text analysis, for our extraction. So after activating the dictionary, we will now create a rule. And this rule has a new name. It's called CrossFit rule.hdb text rule. Any typo will make problems afterwards. And now let's take a look how this rule looks like. So I will now fetch this stuff here, put it into the rule, and now let's take a look what I did. Remove that one. Okay. So this is now one very simple, very basic rule in order to extract information out of the text. And you can see here all the stuff that I've showed you before. All these delimiters and so on. As you can see here, I have some terms that I will reuse later on, which are coupled or put into a subgroups. Like trainee, I have a delimiter, which is an object delimiter, and says if there is anywhere an entity that is type person, I will identify that as a trainee. If I have anywhere something that's an app exercise, where the dictionary comes into play, I extract it as an exercise. And then out of these stuff, I create my groups. So here, for example, I take a clause container, and then I try to match this sentence. So I say trainee, followed by one or many words. Then I want to have something like does, has, was, attended, and so on. So I say I need a token that has somehow the stem of one of these verbs. And then once again, wildcard and the subgroup CrossFit that I reference here, and the subgroup exercise that I reference here. So the what description would have something like that. I can also define the scope here explicitly. It's a little bit different way how to write it. So I can either use these delimiters or this scoping here. What is interesting here is I can also use punctuations as a token. So this what description always uses descriptions that have today and full stop at the end. We will see that later, if that works. And here we have also one other group. It's quite easy to understand. You have the group CrossFit, then you have one or many tokens in between. Then there has to be somewhere the word is, was, and the workout type, and that has to be within one clause. Okay, so that's the rule. We activate it, and that's only possible from release or from revision 90 upwards, from SPS 9 upwards, because before you had to compile these rules out of HANA. So you have to compile them somewhere on your system and then transfer them into the file system of SAP HANA. So that was not really handy. And I'm happy that they changed that. So we have now the dictionary, we have the rule, and now we have to adopt the configuration in order to make the system aware, use this rule, use this dictionary. We already did that before. So we take the extraction stuff and adopt it to our needs. So what we do here is we simply change the dictionary that is used, which is done here. So we use this CrossFit dictionary. And in addition, we have to specify that the system has to use our rule. So we define a new property that's called extraction rule within this configuration and say use our CrossFit rule in order to make the rules processing. So, well, resolution of the beamer is not that good. So as you can see here, it's just a new property dictionaries where we referenced our dictionary and where we referenced our rule for the property extraction rule. So now we have everything in place. And if I made no typo, Pardon?
Didn't you copy configuration and all that? What? Yeah.
Yeah, thanks. Whew. Okay. So what we do now is we simply let this run against the table. So this was the table. We also created before a little index with the, well, configuration core. Well, and it extracted not that many rows. It extracted 2 rows. So that's not too much information. Now let's rebuild the index using our own dictionary, using our own rules. Now let's keep our fingers crossed. Yeah, 16 rows. And now we really extracted everything that we wanted to know. We see here an entity extraction that's a token. And this token is identified as a what type. Whoops, that was not good. I'll hide that one because it's redundant. Okay, so that's what came out. A classical what is the death by pull-up. It's the what type. And as you can see here, it's not only the rules that were used in order to extract the effect extraction, the entity information, but also the dictionary. So there is what, which is the type CrossFit, which is a workout that comes out of the rule, object delimiter, and it has a normalized form. We have the pull-up. We have once again the person, which is also a trainee. So here is the basic extraction that is used due to the extraction configuration core. And here is the one that we have specified in our rule, and so on and so forth. And skin the cat, due to the fact that it's CrossFit, is located as, or is allocated as an exercise, or to be more precise, as an app exercise. You also have here this what description 2. If you remember what description 1 and 2, the difference was the second one had to end with to date full stop, and that was only that sentence that ended with that. So you can see everything. You have really a lot of options in order to do that, and what you see here is you also get a lot of information out of that. You have person, you have trainee, you have CrossFit, you have workout, you have exercise, and so on and so forth. Perhaps you just want to know these entities, what description 1, 2, and so on and so forth. And also, that's possible to tailor it. And that's possible via the configuration file. So you have the option to tell the configuration, use this dictionary, use this rule, but for the full text creation, only send me back the information A, B, and C. And that's possible via the preprocessor. Whoops. So we can add an additional configuration. So now I'm more careful. And say please extract me only the entity types what description 2, and what type. Do not give me any information of the rest that you extracted. I just want those 4. And this configuration part is called the preprocessor. I don't know if anybody of you already worked with SAP HANA. This has nothing to do with the preprocessor within HANA. All text analysis is done within the preprocessor. This is the preprocessing of the text analysis within the preprocessor, for those of you who have more detailed knowledge about SAP HANA. So let's save that and let's see if it works. So we just recreate our full text index. 16 rows now, hopefully more than 0. Yeah. 3 rows, exactly the 3 ones that we have restricted our search to. So as you see, it's not easy, but it's not complicated as hell in order to tailor your text extraction with SAP HANA. And that brings me to the end of this session. So hopefully I could show you that SAP HANA contains a lot of functionality, and one of these basis functionalities of SAP HANA is one that's often forgotten, and it's a very powerful feature, and that's the one of text analysis. This text analysis already delivers a lot of content by SAP, extraction, voice of customer, extraction core of the other ones. But this is usually not enough, and you have all the options to adopt the text analysis. You can build custom dictionaries, you can build custom rules, you can make your configuration to exactly extract what you need. What I mentioned before is that the cool thing is that since SPS 09, the rules get compiled when you activate them within the workbench, which is a very big step forward. And what I also mentioned and what you also saw is it might be a little bit cumbersome to create all this stuff when you come into real world examples, because there is literally no support within the IDE. So there are some basic checks when you activate the rules files so that you put, for example, closing delimiters, but that's it. You will very often, if you work with that, create your full text index, take a look at the table and see 0 rows. So that's something that I think SAP has to work on. And these text analysis, as I mentioned before, perhaps it's not the coolest UI5, you have not the fancy UIs, you have not that other cool stuff, but these text analysis is really the base for a lot of other functionality that you can use within SAP HANA and that you can use at your customer sites in order to get really value to the customer. For example, text analysis is, in most of the cases, a basis for predictive analytics, which is, by the way, also part of SAP HANA. So this is something that is really a very, very nice feature. It's something that you really can try out very easily. And for those of you who will join the hands-on tomorrow, you will get hands on that stuff too. Okay, that's all from my side. Do you have any questions? Yeah?
Do you know if this functionality is using any kind of third-party component? I know that some universities from Great Britain are working on such a sentimental text analyzer. Do you know if this functionality is using or?
No. To be honest, I do not know it. There is also no no documentation what they implemented under the hood. So you, as you saw within the configuration file, you have a lot of cryptic engines or parts that are used for this text analysis, and there is nearly no documentation on that. So the text analysis itself, the stuff that I showed you, it's documented. Some examples are a little bit strange. I don't think that examples using French grammar are really bringing you forward, but that's perhaps just my opinion. But for how it really internally works, there is no documentation, and what's really a little bit sad, there's also no activity on sub-community network in order to give a little bit more insight. So, sorry. Any further questions? Okay, then thank you for your attention.
Thank you very much.